everyone has been put on mute at this stage. So if anyone does have any questions, there's a Q&A box. Feel free to drop us a message or a question in there, and we'll periodically go through those and check them. So like I say, we'll just give it another minute and then we'll get started. Started. So as I said before, my name is Murray. We'll be taking you through today's webinar. I look after fluid power business development for Queensland and the Northern Territory. So some of you people on the webinar I will know, some others I don't, so all welcome. So basically we'll run through a bit of a summary of what we went through a couple of weeks ago with Kent when he was presenting the Safe Hydraulics. So part of that were the hazards and everything we're working through with high pressure hose assemblies and strategies we can do to mitigate those hazards. So basically what we're talking about is working around very high pressures in the environments with hydraulic hoses, flammable fluids and compounds, the high temperatures and the working environments, the risk of things moving of the mechanical components when hoses are removed when under pressure and under load, and the potential for electric shocks and that sort of thing. Gates recommends, a high procedure of periodic inspection for these assemblies to ensure they are replaced before failure. So the importance of developing a standard procedure is so you can have the maintenance and inspections and document everything. So it's critical for everyone involved to follow these to try and reduce the risk of a hose failing and potentially someone getting hurt. So part of what we're running through today and the next course as well is selecting the right product types, building safe assemblies and using proper installation techniques will simplify everything we talked about from last week, and that's what we're going to be covering in the next 5 lessons. So at the end of this session, we'll be able to describe basic construction of hydraulic hose, understand the purpose and variations found in the different layers of hydraulic hose, follow effective troubleshooting procedures around hydraulic hoses, and recommend techniques and value-adding products to maximise assembly life. So the first section here is understanding the hose construction. So there are the main components which make up a hydraulic hose. So the inner tube, which is made of various compounds to basically contain the fluid inside of the hose. I mean, obviously that's the main part of the tube, is to keep the oil or the fluid or whatever we're conveying from escaping. The reinforcement, now this is there to hold everything together, keeps the internal pressures in place, and also works in respects if there's a suction or a vacuum in the system to prevent the hose from collapsing. And the cover protects the tube and reinforcement from heat, abrasion, corrosion, and the harsh environments. So let's have a look first at the tube. So the tube, it's uniquely designed to handle specific applications. As everyone I'm sure can understand, there are lots of different types of fluids out there in the world which hoses need to be able to withstand passing through the internal internals. Most common nitrile tube will handle all generic hydraulic oils. Nitrile is used because it does cover such a wide range of the hydraulic oils which are out there today. In the latest 2019 Gates Product Technical Manual on page C59, you'll also go through and have a look at the compatibility charts. As you'll see over on the right-hand side there, nitrile being the second column along in the top right panel, it has a score of 1 of excellent for your hydraulic fluids, your standard petroleum oils, and a number of other components which go in there. We also have other liners which are used for different types of chemicals. Also in the product technical manual for each of the hoses and their specific information on them, Gates advise what the tube stock is made of. As you can see, we have the MXT hose, and in there it tells us that the tube is a black oil-resistant synthetic rubber, which is nitrile, and it tells us what we're looking at there. So it's very, very handy if you have a customer coming in to use the chemical compatibility chart to ensure you're matching the correct hose liner with the correct fluid which is conveying. So the rule of thumb, there's 3 basic tube stocks recommended for hydraulic applications. We have neoprene, which is standard petroleum-based fluids, nitrile, petroleum and biodegradable fluids, and CPE, which is chlorinated polyethylene. And that's via synthetics and very high temperatures. In the next webinar, we will be talking about selecting the right replacement hose. So we'll be working through the stamped system with this, so you can get a better understanding of selecting the correct tube for the fluid which is conveying. All right, let's have a chat about cover. So the cover does a number of things. So it protects reinforcement by providing resistance to abrasion and environmental factors. It has the same concept of chemical resistance as the tube. If you understand, if the application is an area where there's lots of chemicals on the exterior, then we need to make sure that the outer cover isn't going to be degraded by acids or other chemicals which may be exposed to it. So the primary types of cover include synthetic rubber, which is found on your most hydraulic hoses, urethane for your thermoplastics, and textile type cloth braids for your fleet type hoses. Now, the questions to ask when considering the hose cover as below: are there abrasion concerns where the assembly is routed? Is the assembly exposed to ozone on a regular basis? What weather condition is the assembly operating in? Is the hose cover exposed to any chemicals? Are there any special considerations, high or low temperatures, for example? What industry requirements, exist around the cover for the application? Some customers may specify they need a particular style of cover for their applications. So Gates do offer a wide range of covers, but these are just some of the questions to ask, and we can help when these come up in your discussions with the customer. So let's have a talk about reinforcement. So primarily, these are the types of reinforcement you'll see in hydraulic hoses. So you have a spiral. Now the spiral hose consists of 4 or 6 layers of spiral wire. So it's high tensile steel, extremely high pressure for high impulse applications. These in the Gates world utilise the global spiral series of couplings, which generally speaking are a 2-piece. We have the wire braid, which is a 1 or a 2 wire, commonly referred to 1 wire or 2 wire, high tensile steel wire. These are commonly found in high pressure applications and some medium pressure. Primarily, these are used with the Gates Mega Crimp 1-piece coupling. We have textile reinforcement. Now, these are used for low pressure applications such as power steering, air conditioning and thermoplastic hoses. However, some of the SAE 100 R8 pressures are getting quite high in comparative to a 2-wire application. And we also have the helical wire. Now, these are the suction applications, and this is designed to prevent the tube from collapsing internally with the suction coming from the tank. So we've had a question come through. And this is quite a good one because it comes up every so often when you're talking with people. And what it's asking is the layer of rubber between the 2 wire packs. So if you'd look down to a second image on the right-hand side, you'll see the inner tube, a layer of wire reinforcement, a layer of rubber again, and then the second layer of reinforcement. Now that there is actually a friction liner. It has no benefit for holding or assisting in holding any of the pressure or retaining the pressure from the tube. It's purely there to stop the 2 wires rubbing together. Because as you can imagine, if the 2 wires are going to rub together, it's going to degrade it a lot faster. So that's why they put the friction layer in there to stop them rubbing to give the hose an extended life. It's quite a common misconception that if the outer reinforcement layer is removed by abrasion, that next layer of rubber and the first reinforcement layer is going to be equal to the same working pressure as manufactured with 2 wires. Unfortunately, that's not the case. So, yeah, it's purely there to stop the wires rubbing together. For many people, they may not have seen one of these images before of a braiding machine for putting together a braided hose. So as you can see there, you have the inner tube stock, which has been on the mandrel there. And then on the right-hand image, you can see all the braiding bobbins. Now, they obviously work around the tube and create the weave, which is then the reinforcement of the hose. By the look of this, it's only a 1-wire hose we're currently making at the moment. When you see a 2-wire hose, literally you could see the double amount of bobbins to spin around to create reinforcement layers. So pressure definitions. The rated working pressure of a hose is the maximum pressure to which the hose can be subjected, including momentary spikes in pressure, which can occur during service. The abbreviated is working pressure. You've got surge pressure, which is the peak, so the maximum pressure spikes to be seen in the system, and then burst pressure. Hydraulic hose burst pressures are 4 times the rated working pressure as per the standards. This is the value to which the hose is tested to. So in the image below, you'll see a pressure impulse over a 10-minute period for a hydraulic hose assembly. As you can see, through that time, there are a large number of spikes from a very low pressure to a very high pressure. Now, the hoses are designed and tested to withstand these peak pressures and spikes. So, excuse me, it's interesting to see this from a printout point of view for what the hose is actually having to work through in its day-to-day life. In the example of some high pressure applications, in the top 2 images, you've got an excavator there, which is a rather large mining piece of equipment with a series of boom arch hoses. These are obviously large bore and high pressure, high impulse applications. In the lower 2 pictures, you have some pilot lines coming off the joystick on the excavator for controlling the movements of everything on the machine. These are low impulse applications. So to give you a bit of a breakdown on different areas of the machine, we have the number of different hoses identified on this image here. So we've got the cushion control, so that's a high pressure hose in that application. The lift cylinder, again, is a high pressure application because it'd be lifting a lot of load and moving the implement around. Control valve supply, so that's again a high pressure, generally coming from pump to the control valve, same as the bypass filter to the control valve is considered high pressure. Pump suction is obviously going to be working in a suction application from the tank to the pump. And then the track drives. Now these are very high pressure. As you can understand, the fluid needs to have enough pressure to move the motor to get the machine to move. So every part of the machine has different applications for different styles of hoses and the different pressure ratings that they need to. All right, looking at the tube, the troubleshooting side of things. Now, the problem in this is the blister forming on the hose cover. The cause, can be a number of different things. So it can be incompatible fluids that have permeated the hose tube and collected under the cover. Compressed gases can also permeate through the tube and become trapped under the cover. Or trapped air in the hydraulic system can also cause blisters. Now, one thing to consider when looking at blisters forming on the cover is the blister dry internally or is it wet with oil being the obvious option there? The 2 different answers to that will give you an idea of what's causing the permeation. So the solution to this is replace a hose which is compatible with the fluid if that's the issue. The cover can also be perforated or pinpricked is what it's commonly referred to. This allows the gas to pass through the cover and out into the atmosphere effectively. But something just be careful around there that some of the gases can displace breathable air and or be flammable. So make sure the area is properly ventilated if you're in a position you've got a hose which is permeating any gases. Other causes for that can also be where the hose on the end before assembly, the cut is outside the tolerance allowed, allowing fluid to bypass the end of the hose and then come back down through the outer cover. Okay, the next problem we have is a sluggish or unresponsive equipment due to tube swell. So the way to identify what's wrong is we cut the hose and we've evaluated to see that the tube is swollen and deteriorated, and it's possibly going to be washed out in sections as oil is still going to be trying to pass through there. So the cause for this is likely fluid incompatibility. Excess fluid temperature can also cause the tube to bulge near the end of the coupling. So the solution for this is replace the hose using a tube material recommended for that particular fluid. Obviously, you can understand with this, if we have foreign material going through the hydraulic system, it would need a substantial amount of work to clean all of that out to cause or prevent any other issues with the hydraulic system. So that's where selecting the correct tube for the fluid is imperative when installing a hose. Okay, on this one here, we're looking at the hose tube is cracked or brittle. So the cause is exposure to excessive heat, excuse me, typically due to undersized hose or reservoir. So we were talking about the reservoir, the tank, or maybe the cooler that doesn't have one fitted to that machine. The improper inside diameter will cause excess turbulence and added heat inside of the tube. So the idea is we need to match the correct ID of the hose for the application to get the correct turbulence or speed of the fluid going through the hose. So as you can see on the picture on the top right-hand side, where the oil path is sort of bouncing inside and outside of a hose there, it is going to cause that hose to fail prematurely. So we'd have to look at potentially rerouting that to ensure that that's going to be smooth oil flow for that application. So the solution, select a hose that meets the temperature and flow requirements and compare the pump output to the hose size. So in the product technical catalogue, also on page C69, we have a flow chart there that can be used for this. So it just calculates the flow rate, the hose ID and the fluid velocity to make sure we're in the right zone for the hose sizing. So as you can see at the bottom there, the point that an increase of 7 degrees Celsius above the maximum temperature may decrease the hose life by up to 50%. So it's quite a significant loss in life of the hose. All right, let's have a look at some reinforcement troubleshooting. All right, so here we have a hose burst at the body or some pinhole leaks. So it causes excessive pressure surges, high impulse causes sudden failure, excessive flexing or kinking or crushing, so gradual fatigue causes eventual failure, like bending a paper clip until it breaks as an example of that. Exceeding minimum bend radius, so it's bending the hose tighter than recommended, and that's going to place excessive stress on the reinforcement. Gaps form between strands of a reinforcement, severely reducing the hose's ability to withstand pressure. So the solution, review or inspect your operating pressures and surges using the pressure transducer. From there, we select a hose that has the proper working pressure rating to handle the maximum pressure, including the surges for that application. If the application does have frequent pressure surges, we may want to consider putting a spiral reinforced hose rather than a wire braid reinforced hose. The other options are we can reroute to eliminate excessive flexing and or exceeding the minimum recommended bend radius, or using a hose with a smaller bend radius if that's something we can do. So here's a graphic of the minimum bend radius. So as you can see, the image on the left-hand side there is correct. The minimum bend radius for hose is not going past that point. On the picture to the right, you can see where the hose has been extended past that point. Also, I'm sure you can understand that oil likes going in a straight line. So if a hose is trying to bend around a corner, we want to try and make that as easy as possible for that oil to have a smooth going around the corner. A sharp, tight bend will, cause some heat involved in that inner tube being degraded, and the hose will fail prematurely. All right, so let's have a look at this one with a hose assembly which is twisted. First, we'll probably have a look at the image, will be the best one so we can understand what we're looking at here. The hose with the two 90-degree couplings running from the left to the right, as you can see, has a twist in it. Now, easiest way you can see this is the ley line of the hose is going in a wave pattern effectively. So it's basically misaligned. It's not going to do wonders for the internal structure of the hose. So to give you an idea, a twist of as little as 7 degrees may reduce the service life as much as 90%. So a number of different causes can be attributed to this. One, the assembly is too short and has been forced into position. Moving components have twisted the hose after installation, and hose routing that can be improved. The other option is looking at this one with the two 90-degree couplings is the coupling orientation. is not accurate for the application. So there's something to be when assembling the hose at the start to make sure the orientation is correct. So the solution to this is replace and reroute the hose to ensure the bend occurs only on one plane. When installing the assembly, hold the backup nut to prevent it from turning and applying a twist. As I'm sure many people will know, JIC couplings have a tendency to twist when tightening them up to the correct torque. The way around that is you use a spanner on the backing hex to stop that from happening. And if you have a male and a female coupling on the same hose, install the male end first and tighten that, then tighten the female swivel after that. Okay, the next problem we're looking at is hose crushed or collapsed. So the causes for pressure line, the hose has been kinked or otherwise it's been routed incorrectly. The vacuum lines, the vacuum in the system has exceeded the vacuum rating of the hose. So the hose is meant to be used for a pressure line, but it's being used for a suction line instead. Solution for this is to reroute the hose to keep the bend radius as long as possible. Select the hose meant for vacuum suction applications with the appropriate vacuum rating. So as you can see in the image below in the centre there's the wrong way to route the hose, where it's going to kink the hose over, where it's coming straight out, and then the correct or the right way of doing it with a nice swept arc. Now, let's have a look at some cover troubleshooting. So the problem in this one here, we're looking at abrasion damage to the hose. So part of a hose cover has been removed, exposure of the hose reinforcement as visibly seen there. Exposed hose reinforcement is susceptible to rust and accelerated damage leading to failure. So the cause of this, continuous rubbing against other objects in the operating environment, non-compatible fluids such as toxic chemicals, acids, detergents, and non-compatible hydraulic fluids. So this goes back to what we were talking about earlier, ensuring that cover is applicable for the application it's going into for any of those toxic environments with acids, detergents, etc. So the solution is rerouting the hose, bundle hoses together which flex in the same direction. A lot of people get this wrong where they have pressure and return lines and they cable tie them together, but unfortunately they work together and they rub against each other as they're moving in different directions. Clamps, bent tube couplings, nylon ties, spring guards and sleeves can be used to keep hoses away from abrasion sources. There's other ways to protect the hose with nylon or urethane style sleeving, and spring guards can be used to protect the cover in very high abrasion applications. Or we can also look at changing the hose to a cover that's compatible with the chemicals it may be in contact with. Okay, so the next problem is hose cover has cracks and appears to be hardened. Okay, so possible causes, exposures to excessive heat and or ozone. Excessive heat can be created by routing too near heat sources such as exhaust manifolds. So yeah, the solutions around that would be, select the hose with the temperature requirements for the application and identify the heat sources and consider rerouting to minimise the heat's effect. So a bit of a recap on what we've just been looking at there. So we'll start from the top left with fluid incompatible with the tube material has caused the bubbling of the hose. So we need to refer to the chemical resistance table to obtain the proper recommendation. Below that, we have the abrasion to hose cover. So to rectify this, we can reroute the hose assembly, use a higher grade of cover material, or install hose protection. To the very bottom image there, the hose burst at the body, use a higher rated hose and working pressure and or burst pressure, or reroute the assembly using a longer bend radius as possible. To the top right, we have the hose is cracked and appears to be hardened. So select a hose with a higher temperature rating or install some hose protection for that there to keep the heat away from it. And the other image on the right is the hose has been crushed or kinked. As you can see in that image, it's obviously been kinked over right after the crimp there. So we need to either reroute the assembly using a longer bend radius or a longer length of hose as required, or see how we can reroute that to remove that option of it kinking over. So value adding, something we've talked about greatly in what we do. So in respect to the covers, Gates offers 3 different covers and the synthetic rubber hoses. So we have our standard cover, we have our extra tough cover, which is 25 times the abrasive resistance compared to the standard cover, and mega tough cover, which is 300 times abrasion resistant compared to the standard cover. So the mega tough was tested at 1 million cycles without fail in the abrasion testing. So with the extra tough cover, it gives you increased service life. It's still versatile, flexible and easily managed. With the extra tough cover, with the new product coming to the market soon, which is coming out with the extra tough plus cover. So that's featured on the MXG 4K. That's been tested to 250 degrees Fahrenheit working pressure, and it has the increased ozone resistance for this hose. And then going through to the mega tough cover, which is realistically the Rolls Royce is the best way of describing it of the covers in the market. So the Gates Mega Tough hose, it's got exceptional resistance. It maintains its flexibility and the minimum bend radius. It's got good resistance for oil, ozone, and UV rays. And like I say, it was tested to 1 million cycles under ISO standards of the metal to hose rubbing and without failure. So sometimes people talk about adding on a sleeve or some other form of abrasion resistance. It could be another option to look at an economical point of view of upgrading the hose cover that you're offering to the end user. All right, so lifeguard sleeving. So there's an ISO standard, which is 3457, which calls for line of sight protection for hoses within 1 metre of operators. So the lifeguard sleeving, a burst or a pinhole leak, can cause serious problems, ranging from injury, burns, the cost of cleaning the oil up, damage to other parts of equipment and that side of things. And the worst thing is possibly if someone gets an oil injection injury and has to go to hospital for that. So Gates engineered the first sleeve system to protect operators, equipment and the environment from hazards of catastrophic hose failure. The lifeguard effectively contains and redirects fluids in a hose burst up to 10,000 psi. So it does this by going obviously over the hose and being clamped at both ends. The oil has a channel and a path to come out near the coupling. Lifeguard controls pinhole leaks up to 5,000 psi at 250 degrees Fahrenheit for up to 5 minutes. And it can contain bursts of up to 10,000 psi. It's done this on a number of different layers. So it's got the inner nylon layer controlling sudden pressure hydraulic bursts and pinhole leaks. So it's not a single layer. If anyone's seen it, it's got a couple of layers in the construction of it to keep the oil so it's not squirting out or going everywhere. Other hose protection, heat guard. So is heat resistant protective sleeving that can be clamped on to the hose. Protects up to 260 degrees Celsius continuously and up to 1094 Celsius for 15 to 20 minutes. Poly sleeve is spiral wrap designed to protect hose bundles, protects from chafing, rubbing, crushing and UV rays, and can be installed after the hose assembly is in place. We have nylon protective sleeving. It's excellent for abrasion resistant and hose bundling. And we have vinyl bend restrictors fitted to the end of the hose. So they're PVC sleeve and they're basically to reduce the stress which is on the end of the hose coupling. And that sort of concludes where we're at for today on that construction of a hose. What we'll just do is we'll just have a look through now to see if there are any Q&As. Doesn't seem to be anything more which has come through at the moment. But if you have any questions or any other comments or anything you'd like to know more about this program, you can get in contact with Ken Clark, the product manager for Gates Australia. His email's on the screen there. And we have another couple of webinars coming up on the 7th of July, and that's building the right replacement assembly. And then the 21st of July, which is coupling, construction and failure modes. And as everyone's aware, obviously in these times at the moment, people are out and about seeing people, but Gates offer the service of video chats, phone meetings, and all that side of things. So yeah, you can feel free to get in contact with any of us on the team at any time and go from there. So I'll just check to see if we've got any other questions come in. No, there doesn't seem to be anything there at the moment. If anyone's got anything they'd like to ask, feel to put something in now to go for it. We'll give it a moment. All right, not much coming in there now, so that's okay. All right, well, what we'll do, we might wrap it up there. I hope that everyone got something out of that, and that, you know, if there's any other questions, feel free to get in contact with any of us at Gates, and we can answer those questions for you as they come up. But if not, I thank you for your time, and we will finish it there.